Good afternoon. Welcome to homework problem 2.18. Um, so I've got a very rudimentary drawing up there. I'm going to talk about the problem statement. Then I'm going to pause the video and put some more, some more of the given information in there. We'll come back from the pause. It'll be magically appear on the screen. So the problem statement is, and you guys can look at it in the book just as well as I can. There's a boom member ABC that could be raised or lowered by the hydraulic cylinder. There's a cylinder pushing on point B, and the force is 1650 pounds pushing up, and that's indicated by the dotted line, I think, on the picture in the book. We're asked to find components of this force that are parallel to and perpendicular to member ABC. So I've labeled those two forces on this drawing. I'm using L for the parallel force because parallel ends with L, and R for the perpendicular force, you guessed it, because perpendicular ends with R. All right. I am thinking, I'm not sure this is the only way to do it, but this is the way I'm thinking about doing it anyway, and the way I did it last night was, this, we might at this point in the semester look at this problem and say, well, why don't we do it like a structure, right? We can look at the reactions of the supports at A and D. We've got that force hanging off at C. Couldn't we look at it as a problem equilibrium? And I was thinking about that last night, but we don't really know what the force at point C is, right? We don't know how much that object weighs. So I don't think we have enough information to do it using equilibrium equations and the methods from chapter 6. So then I thought to myself, well, if we don't know that, what do we know? So I'm looking at the triangle here, and I'm like, man, if I knew this angle right here, and I'm going to call it theta. If I knew theta, I could use the trig functions, right? Because I've got a hypotenuse and an angle, and that would, using cosine, sine, and tangent, I'd be able to get both side R and side L. Okay, I don't know theta, but I know that theta is a vertical angle to this angle. So this is also equal to theta, right? Vertical angles, two angles that intersect, create two sets of vertical angles, which is a great fact for us to know, especially since we need one of them. Do I have enough information to get the measurement of this vertical angle? All right, so I'm gonna pause the video and draw in the rest of the information that we have. I'll be right back. Don't go away. All right, so I went back in my picture or my drawing and kind of filled in some of the stuff that's given in the picture in the book. So remember before I paused it, I'm looking for theta. I think that's the key. Using right triangle arithmetic or trigonometry, if I have theta in the hypotenuse, I can get side L and side R. There's a set of vertical angles right there. So if I could only figure out theta on the, let's call it the left-hand side, I've got theta for the right-hand side, right? Because they're vertical angles. So I'm noticing a couple things. So this is a right angle. Right? Looking at the picture in the book, you probably also see it as a right angle. I think so if that's a right angle, and it is composed of three pieces, the piece I'm putting a dot on right now, our theta, and the second dot, those three angles equal 90 degrees if you add them up. I can calculate both of the dots. I know how big each of the angles are for those dots. I think so anyway. So let's look at this top one. So it's the triangle with the 14-inch and a 26-inch leg. Hey, looking at that triangle, oh, you guys deserve better than that. I mean, I have a straight line maker in the drawing here. So let me try to take advantage of it where possible. There we go. While I'm here, I'm gonna draw the other one, just so I don't have to click again. Okay, all right. So 26 inches, 14 inches. I'm looking for this right here. So I'm gonna use tangent. So tangent, we'll call it tangent of angle A is equal to 14 over 26. Angle A is equal to inverse tangent 14 over 26. And if you put that in the calculator, it's 28.3 degrees. This bottom triangle, 26 inches, 52 inches. We'll call this one angle B. Tangent of angle B is 26 over 52. So B is equal to inverse tan of 26 over 52, which comes out to be 26.57 degrees. So now I know this one here. I'm going to put it in a different color. Oh boy, not a lot to choose from. So we'll use brown. So that's 26.57 degrees. This first one we calculated was 28.3 degrees. And I think I've stated already that 28.3 plus theta plus 26.57 degrees equals 90. So 90 minus 28.3 minus 26.57, we get that theta is equal to 35.87, so 35.13 degrees. That was not a very good looking 90. All right, so that gives us theta. So after that, to me, a little bit anticlimactic. $1,650 R L. I'm gonna rewrite L. L 3513. All right, so a little bit anticlimactic from that point. Certainly we can say that the sine of 35.13 degrees is equal to R divided by 1,650. R then is equal to 949.47 pounds. Well, I left my units off all over the place, didn't I? And cosine 53, nope, backwards. Cosine of 3513 degrees is equal to L over 1,650. So L would be equal to 1349.12 pounds. That was our problem statement. Calculate R and L. Pictorially, I mean, I don't know if I would have written the final answer for this one pictorially or not. but we will just in case someone's interested. $949.47 pounds. 1349.12 pounds. 1650 pounds. 35.13 degrees. And to finish it off, I think this was given as, nope, it's not given as anything. Okay. So numerically, pictorially, problem 2.18. I'll see you guys in a couple minutes for our last problem.